Welcome to the lesson on solar energy. In this lesson, we will provide you with the fundamentals of solar energy, including harnessing solar energy, some of the challenges, and the advancements in solar technology. Let us look at our lesson objectives. By the end of this lesson, you will be able to explain the methods used to harness solar energy. Next, you will be able to describe some of the challenges that arise for solar panels. Later, you will be able to name some of the new developments in solar technology. Finally, you will be able to explain how solar energy influences BEV manufacturing. So, what is solar energy? Solar energy is the technology that converts sunlight into usable electricity using specialized panels and systems. Solar energy is electricity made from sunlight using two main methods: solar panels and solar heat systems. Solar energy has been used for thousands of years, with ancient civilizations using passive solar techniques for heating and lighting. The development of photovoltaic, abbreviated as PV, cells in the 1950s was a significant milestone, leading to the commercial production of solar panels. Photovoltaic, PV cells, also known as solar cells, are devices that convert sunlight directly into electricity. They are made of semiconductor materials, such as silicon, that absorb photons of light and release electrons. These electrons are then collected and converted into an electric current. PV cells are the basic building blocks of solar panels. Solar panels are made up of multiple PV cells connected in series and/or parallel. The number and configuration of PV cells in a solar panel determine its power output. PV cells work using the photovoltaic effect, which is the generation of voltage or electric current in a semiconductor material when exposed to light. The image is a vintage illustration of a solar-powered Victorian newspaper printing press in the 19th century. The reflectors concentrate the sun's rays upon a boiler to generate steam. Abel Piffre, 1852 to 1928, was a French engineer who developed the first solar-powered printing press. Solar energy has two primary forms: light and heat. We can turn this energy into electricity using two different methods. They are solar photovoltaic, PV cells, and concentrated solar power, abbreviated as CSP. The first method is solar photovoltaic cells that turns light into electricity. The next method is concentrated solar power that turns heat into electricity. Solar photovoltaic cells work by capturing light and converting it directly into electricity. These specialized panels contain semiconductor materials designed to interact with sunlight in a unique way. When photons, tiny particles of electromagnetic radiation, strike the panel, they cause electrons to break free from their atomic structure. These electrons create an electric current, turning sunlight into usable electrical energy. This happens through carefully engineered layers of N-type and P-type materials that have different electrical charges, which facilitate the movement of electrons and generation of electricity. The next primary method to harness energy is concentrated solar power. CSP systems take a different approach by harnessing the sun's heat. These systems use large, precisely angled mirrors to concentrate sunlight onto a specific receiver. The concentrated sunlight heats a special liquid, which can be molten salt, oil, or another heat-retaining fluid, to extremely high temperatures. This heated liquid then produces steam, which drives a turbine connected to an electrical generator. By converting solar heat into mechanical energy and then into electricity, CSP systems provide another innovative method of generating power from the sun. How do solar panels work? Solar panels use light from the sun to create electricity. When sunlight hits special materials called semiconductors, it causes tiny particles called electrons to move, creating an electric current. The panel uses two different types of materials that help electrons flow and generate power. How do solar heat systems work? Solar heat systems use mirrors to focus sunlight onto a special liquid. The sunlight heats the liquid, which then creates steam. The steam spins a turbine, and this spinning motion generates electricity. It's like how a windmill works, but using heat from the sun instead of wind. How are solar panels constructed? Making a solar panel involves three main steps. First, scientists create special wafers that will become solar cells. Next, they turn these wafers into individual solar cells. Finally, they carefully assemble these cells into complete solar panels. The most common material used is silicon, a semiconductor that can effectively capture sunlight and convert it into electricity. Solar power conditioning transforms the direct current, abbreviated as DC power generated by solar panels, into alternating current, abbreviated as AC power, suitable for use in electrical grids. Inverters are crucial in this process, converting power and providing control, monitoring, and safety functions. These systems must comply with electrical standards and safety regulations. Solar panel performance depends heavily on correct installation, especially how they are positioned toward the sun. Several factors can reduce their effectiveness. Shadows from nearby objects, dust and debris accumulation, and high temperatures can all decrease voltage and energy production. Solar power isn't practical everywhere due to variations in sunlight and available space. A comprehensive life cycle assessment is crucial to evaluate the environmental impact of solar systems, from material sourcing to manufacturing, installation, and eventual disposal. Sustainable practices include minimizing waste, recycling materials, and responsibly managing old or damaged panels. New inverter technologies are improving solar power systems. String inverters process power from multiple panels, meaning they convert the entire string of solar panels' direct current electricity into usable alternating current electricity in a single, centralized unit, making them a straightforward and affordable solar power solution. Microinverters and power optimizers offer enhanced performance and monitoring, meaning they're installed on each individual solar panel, allowing for better performance tracking, more precise energy conversion, and the ability to optimize power output even if some panels are partially shaded. Hybrid inverters can now store energy in addition to supplying the grid. Grid-forming inverters are particularly valuable in areas with unstable electrical infrastructure, enabling standalone solar power systems. These advanced inverters can not only convert solar energy but also integrate energy storage systems, enable backup power during outages, and allow solar systems to operate independently from the main electrical grid when needed. New advances are changing how solar panels are made. Scientists have developed perovskite solar cells, which are both more efficient and cheaper to produce. A new manufacturing technique called roll-to-roll production allows for continuous panel creation, which helps reduce costs. Researchers are also creating flexible solar panels that could be installed on many different surfaces. Scientists are constantly improving solar panel technology. They are creating more efficient materials like cadmium telluride and non-crystalline silicon. Innovative designs now include double-sided panels and panels integrated directly into building surfaces. Some exciting new developments even include floating solar arrays that can be placed on water instead of land. Recent developments focus on improving solar power's efficiency and sustainability. Designers are finding ways to reuse and recycle solar panels and components. Innovative applications are emerging, such as solar-powered BEV charging stations and water desalination plants. Urban planners are also integrating solar solutions into building codes and developing supportive policies. Various financial incentives make solar power more affordable for individuals and businesses. These include tax credits, rebates, and grants that help offset the initial cost of solar installations. Net metering policies allow solar system owners to receive credits for excess electricity they feed back into the grid. Some programs even offer feed-in tariffs that guarantee premium rates for solar power producers. Feed-in tariffs are financial policies where utility companies pay solar panel owners a fixed, typically higher than market rate for the excess electricity they generate and feed back into the electrical grid, essentially allowing homeowners and businesses to earn money by producing clean, renewable energy. Emerging incentive programs are becoming more innovative. Performance-based incentives like solar renewable energy certificates, abbreviated as SRECs, provide financial benefits for large producers in the U.S. Community solar programs enable individuals to subscribe to shared solar installations and receive bill credits. There's also a growing focus on creating incentive programs for underserved and low-income communities to ensure more equitable access to solar energy. Let's look at how solar energy influences BEV manufacturing. Solar panels can provide clean energy to run the machines and tools in BEV factories, reducing the use of fossil fuels. Solar energy can be used to charge the batteries of BEVs, both during testing in the factory and after the vehicles are sold. Using solar power in manufacturing helps make the entire BEV production process more environmentally friendly by cutting down on pollution. Let us now look at our lesson summary on solar energy. Light and heat are the two primary forms of solar energy utilized, with photovoltaic cells converting sunlight directly into electricity, while solar thermal systems capture heat for various applications. Solar panels are employed in various industries, including manufacturing processes and the production of power for BEVs, demonstrating their versatility and growing importance in sustainable energy solutions. Proper installation and minimal shading are crucial for optimal solar panel performance, as factors such as dust and heat can significantly reduce the efficiency and energy output of solar energy systems. Advances in materials, design, and applications are driving solar power innovation, with researchers and engineers continuously developing more efficient, cost-effective, and adaptable solar technologies. Government incentives like tax credits, rebates, net metering, and feed-in tariffs make solar power more affordable, encouraging broader adoption of renewable energy systems by reducing the initial financial barriers for consumers and businesses. Solar energy helps make BEV manufacturing cleaner by powering factories and charging vehicles with renewable energy, reducing pollution. Thank you.